Hey, welcome back. We are going to do some time series forecasting using a moving average 5 and a moving average 10 method. We'll then compare the errors of those two forecasts to see which one would have given us the least biased and or most precise estimate using historical data. So let's just start by looking at the data that we have. In columns A and B, we've got a time variable, which is month, and we've got a units of measurement variable, which is sales. If we were to take these two variables and plot them on a graph, we can get a sense visually for how demand has fluctuated over time. And when we look at our sales, we can see that there's a somewhat random and non-predictable pattern. That means that sales have been, not necessarily consistent, but they aren't growing. Like we don't have a product that has seen a growing level of demand over time, nor do we have a product that has a declining level of demand over time. Also, there are no regular and predictable seasonal changes, so we don't have a product that, say, like swimsuits that sells a lot in the summer but not in the winter. So let's just take a look at, let's just label this. We've got unit sales over time, and then I'm going to adjust this axis here so that it only goes to month 25. And then I'm going to adjust this axis so it starts more at like 20 units, and that'll just make the data take up more space on that chart, and it'll allow me to still see the pattern even though I want to move it out of the way. So I have got unit sales by month. A good tip is to spend some time when you make a graph labeling it. The reason for that is that if you come back and you want to look at your data or look at the work you've done, you don't want to have to spend a lot of time trying to remember what you've done. All right, and if you have a graph that's labeled and it tells the whole story with a nice title and two labeled axes, you're not going to have to spend a lot of time backtracking to remember what the heck you did. So this is our pattern of sales. I also want to calculate some descriptive statistics, right? What were our average sales? Equals average is the formula in Excel. So we sold on average 49 units. And looking at the graph, that makes sense, right? We've sold about 49 units. And the variance on those sales, I'm going to use var.s because I'm going to treat this like a sample of data. Our variance is 24.82. And if we calculate the standard deviation is the square root of the variance, so we know here we're going to be at about 5. So our standard deviation is 4.98. So we've sold 49 on average, plus or minus about 5 will get us most of our data points. Our minimum is the fewest number of units we've sold in a month. So we've sold 38 or more, right? 38 is our smallest sales. And our maximum is the largest number that we've sold, and that's going to be 60. So 49 plus or minus 5 with a minimum of 38 and a maximum of 60. And we can see that we have 24 months of data, but oftentimes if you're dealing with years or quarters, it's nice to just have a number here that says, oh yes, we've got 24 months of data. So looking into the future, we've sold 49 on average. How many are we likely to sell in the future? We're going to compare a moving average forecast using an MA5, comparing that to an MA10. With an MA5 forecast, moving average 5, we come up with next month's forecast by averaging the previous 5 months of values. So my average for month 25 is going to be, my forecast for month 25 is going to be the average of months 20 through 24. Using an MA5 method, our forecast for month 25 would be 48.4. Using an MA10, my forecast for month 25 is going to be the average of the previous 10 months. So our MA5 predicts that we'll sell 48.4 units, where MA10 would predict that we'd sell 49.6 units. So the question then just becomes, which of these forecasts is likely to be better? Which one is going to be ideally less biased, right? It's going to underpredict or overpredict the same amount. And which one is going to be more precise? Which one is likely to be closest to the actual value? Those things are actually slightly different questions. So we're going to calculate a series of errors that will help us answer that question. So what we need to know to evaluate a forecast is how well would it have worked historically, right? How well would an MA5 forecast have predicted month 17? How well would it have predicted month 18, month 19, right? So on and so forth. So what we're going to do is create what I'm calling a historical forecast. It's using historical data to forecast values that we actually already know, right? We actually already know what we sold in month 17, but we can pretend we try to predict it. Then we can see how well we were, how well this forecast worked, whether or not we were off, right? So to do that, for month 17, if we wanted to predict month 17 using an MA5, we would average the 5 months before month 17. That would give us 51.2. We could enter that individually for months 17 to 24, or we can just drag down that formula. The thing to note is that as we click in each of these forecasts, each of these historical forecasts, you can see that the 5 cells, historical cells that it's referencing moves, right? It's a moving average. It's because each month you take the previous 5 months, and then when the next month comes along, you drop that oldest month and pick up the most recent month. So this here is our moving average forecast, moving average 5, our historical forecast. I chose months 17 to 24 to make a historical forecast somewhat arbitrarily. You would have to look at your own situation. If you're in a business, think what's going to be most relevant to you, possibly choose a couple different time periods and compare them, or it would be given to you in a problem if you're a student. So for each of these, we're going to figure out how far off we were. Our error is our forecasted value minus our actual value. And it tells us both whether we were over or under, in other words, whether we overestimated or underestimated, and by how much. So here our error is negative 0.8. That means that we underestimated by 0.8 of a unit. And you can see that here. We predicted 51.2 units, but we actually sold 52, so we were under by 0.8 of a unit. The absolute value of that error is useful because it tells us how far away we were, which is different than saying whether we over or we underestimated. The absolute value is also nice because if you average a bunch of absolute values, you're not going to average the positive and negatives. You're not going to average all that away. You'll keep that value. So we use the absolute value, ABS, of negative 0.8 means that we were off by 0.8 of a unit. So here we were under by 0.8. But that's 0.8 away. Small distinction, but an important one. The squared error is just our original error squared. To square, you use Shift 6 to get that caret, and then you put in the 2, and that will square it. And then the absolute percentage error basically says how far off were we as a percentage. So we take the absolute value, 0.8. We were off by 0.8 of a unit. Doesn't matter if we were over or under, just we were off by 0.8 on a real demand of 52 units. So we were off by 1.5%. If you're not getting your numbers like these, percentage, you can come up from the drop-down menu and choose percentage. I'm going to restrict it to 1 decimal, or you can use this percentage button. Once we've got these, you do not have to enter it all the time, for each of those historical forecast months. We just drag it down, and that will populate our box. So our question that we're asking ourselves is, how well did we do on average, right? How well would this MA5 forecast performed on average? And we can evaluate that because we don't have to wait for 10 more months to pass for us to know how well that forecast did. We can just use that method on our historical data and say to ourselves, how well would this have worked? So on average, our mean error is our average error. We would love it if that number was 0. A mean error of 0. Don't let it do that to you. Those don't mean anything. Our mean error, if it's 0, it tells us that we overestimated and underestimated about the same amount of times, and the magnitude of those over and underestimations are balanced such that it averages out to 0. When we have a mean error of 1.25, that means that on average, it's positive, right? So on average, we overestimated by about 1.25 units. We can kind of interpret that as a way of saying that our forecast is slightly biased. It's likely to overestimate rather than underestimate. The absolute error, I'm just going to drag this one more over, tells us how far off we were. So this one tells us that we've overestimated by 1.25 units on average, whereas this one tells us that while overestimating, we're still about 2.45 units away from the target, above or below. It's a measure, absolute value, it's a distance measure. We're 2.45 units away from the actual measure. I'm going to drag 2 more over and then talk about the mean absolute percentage error. The mean absolute percentage error just asks us how far off are we as a percent. It's probably our most intuitive measure, right? We're 5% off. Our forecasts are off by about 5%. So we overestimate by 1.25. That's our mean error. It's our measure of bias. Whereas these 3 things, the mean absolute deviation, the mean squared error, and the mean absolute percentage error, those tell us about precision. How precise is our forecast? And we can interpret these as saying we're off by about 2.45 units on average, and that's about 5% of our actual value. Our forecasts have been off from their real level by about 5%. And so if the past and the future look similar, which based on this data, we can expect kind of an average value of sales plus or minus a little bit of random fluctuation for reasons that the time series at least cannot capture. We would say that with the MA5, we're forecasting 48.5 plus or minus 2.5 units roughly on average, or about 5%. So that's what this forecast tells us. I don't want to keep you forever on this video, but I'll show you quickly how to, actually no, I'm not going to show you anything else. Otherwise, you'll be here forever. All right. Happy calculating, and I will see you in the next video.